Hi everyone. Welcome back to week 3 discussion on naming ionic and covalent compounds. I should have learned this from my good friend who always said never say never. And I believe I said we're going to wrap up week 3, and as I was going back through my videos, I realized I should have actually told you about naming ionic and transition metal compounds with polyatomic ions. Okay, let me repeat it. I was going to reserve the polar and the polar covalent compounds and compounds with hydrogen bonding and van der Waals forces for week 4, but I did not realize I did not record a video for ionic and transition metal compounds with polyatomic ions. Okay, so the rules doesn't change. Whatever rule you applied for ionic compound and transition metal compound, most of the rules stay the same. The only difference being the anion or the negatively charged ion used to be like just a single element. Okay, but this time around we have a negative ion that's got a multiple element combination. Okay, let me actually walk you through what we did and what we are going to learn. Okay, so let me get my pen. Okay, so here's what we learned. Okay, like for instance, we learned about Na, say Na3N. Okay, all right, and then we learned about say FeCl2. Now if you notice, okay, what I'm saying here is just because there's 2 chlorines does not make it polyatomic. Okay, you got only, let me get a different color so I can highlight what I'm trying to say really, so when I explain the reminder of what I'm going to explain, it'll make sense. You see, you got just 1 nitrogen, right? Similarly, you may have 2 chlorines. Okay, yes, I do see 2 chlorines right here, but both are chlorine. Okay, so technically this is not polyatomic. Okay, not polyatomic. Now while I'm here, let's see if any of you could figure out the names for these 2. This we have learned, okay, in week 3. When I explained ionic compounds and when I explained transition metal compounds, I gave you multiple examples on how to name these. So if you want, take the time and please pause the video as you wish. I'll tell you probably when to pause. I'm just rewriting these compounds, okay, just as a good measure. Okay, see if you did master this idea. Go ahead and pause the video right at this point and write the names, the chemical name for the ionic compound and the transition metal compound. All right, go ahead and pause the video now. All right, assuming you have done your hard work, you should have had, remember I said when you do ionic compounds, the metal always comes first, and that is written with absolutely no changes. So it'll be sodium, right? All right, now for the nitrogen, I told you, you got to memorize those 5 or 6 things. Whenever you have a GEN, it changes to, and I mean they all change to IDE, but you need to know which 3 letters or which 4 letters you're changing it to IDE. Nitrogen obviously ends with a gen, so the gen changes to ide. So nitrogen would become nitride. Now because this is a alkali metal, remember I said for alkali and alkaline earth metals we don't use Roman numerals, okay, because they're always going to lose. For instance, sodium is in 1A and it's a metal, so it's only going to lose 1 electron, right? Very good. Whereas this right here is a transition metal. So, I told you how to write. Again, we don't make any changes or adding any suffix to the metal, it stays the same. And how did I teach you how to go about figuring out the Roman numeral and then write the remainder of the name? Now, chlorine, okay, let me write it here. Chlorine, if you reverse map it, it's 7A. If I'm correct, it's 7A. And it has to get to 8A. And how is it going to do that? It's going to take 1 electron to get to the 8, right? So, that means it's Cl1 minus, right? That's 1 minus. There's 2 of them, right? But for now, let's just focus on this. It's 1 minus, right? And we know this is chloride, because chlorine, I think I and E becomes IED, IDE. So, it's this right here that needs to be addressed, right? So, if you keep that in mind, this step is just to reinforce the idea on what we did. You could even do it without doing this process, okay? So, that means we just simply cross swap it. So, if you write this again, basically imagine there's a 1. So, the 1 goes here, the 2 goes here. That means you will technically end up with Fe2 plus, right? And Cl is 1 minus, right? That's how you end up with the charge. Now, we know this is 2 plus. So, iron 2. Okay, I made a mistake here. If any of you have noticed, I left it as iron 2 chloride. That's not right. It's iron 2 chloride, right? So, this is how we learned. Now, none of these is polyatomic. You see, there's only 2 elements in all these compounds, right? Whereas, what we are going to look at next is, okay, I'm going to write the title for this. So, it's ionic and transition metal compounds, okay, compounds with polyatomic ions, okay, polyatomic. In particular, we're referring to polyatomic anions. That's what we're really focusing on, okay. We're not going to focus on any polyatomic positive ion. We are simply going to focus only on the polyatomic anions, okay. So, that's what we have in front of us, okay. Very good. Now, let me bring up something that I have for you. It's in the slides that I've posted. It's in the ionic compound slides. Now, there is no other way. You just have to remember these, okay. I've condensed it to just what, 6 and then 7. So, you do have to remember this, okay. There is no getting around it. You just have to remember these 7, okay. All right. With that in mind, I'm going to walk you through a few examples on how we go about actually doing this, all right. So, again, we're going to look at both the given the formulae, how to write a name, and given a name, how to write a formulae. Let's start with, since we have learned it, it really doesn't matter which order we go from. So, let's say I give you the name first, okay, iron 2 carbonate, okay. Now, what you have to really keep in mind, and where I have seen students struggle, is this right here. I'm going to show you exactly what the mistake they do and how to avoid it, all right. Now, the first part is very easy. This rule doesn't change. This 2 is only tagged to the iron. So, we know iron is +2. Now, as I said, there is no getting around it. You can come up with your own mnemonic, but carbonate is CO3 2 minus. Now, all you have to focus are I'm going to get my different color so I can circle you, because this little 3 for the oxygen is going to throw a lot of people away, especially if this is their first time around looking at anything like this. All right, you are only going to focus on the pluses and the minus. Don't worry about the 3. This is what makes it polyatomic in the first place. Okay. All right, that's what makes it polyatomic in the first place. Now, what students do is they unnecessarily complicate things, like many of us do that teaches the class as well. So the 3 has really no meaning in the context here as far as swapping. Okay, so all you are going to do is, if this becomes a problem for you, I have an alternate suggestion for you. You do have to still memorize it. I'm going to teach you both ways, and you decide what works for you. Okay, this is the way I write it. Okay, this is for people to avoid getting mixed up with the 3. Okay, well, again, there is no getting around it, you memorizing the carbonate. Okay, there is absolutely no other go. That's a roadblock. You just have to get over it. All right, if this bracket doesn't bother you as much, then simply swap the 2 here and the 2 here. Remember when I said, whenever you have a 2 and a 2, that's an easy situation. Maybe when we look at another example, then this is how you do it. It's easy, right? And it's the same here. The reason is, what people I have seen do is, for different cases, they simply write the 2 here, the one that they swap, as if it is oxygen 32. Well, that's the way they are seeing it. You can't blame them if you tell them to swap. Well, they're going to put it right next to where they see it's likely going to go. Now, you can also do it this way for all polyatomic. Put all the elements with the subscripts inside a bracket and just put whatever the negative charge is outside the bracket. So there is really no chance for you to mess it up. So let's go get a different color. So you put the 2, you put the 2. Now you have to leave, if you're going to start with the bracket, leave with the bracket on. Since it's 2 and 2, there is no problem. All right, let's go look at another example where things can be a little tricky. Okay. All right, we looked at iron 2 carbonate, right? How about let's look at iron 3 carbonate. Okay, iron 3 carbonate. Okay. Now this is where I was telling most of you that where students make the mistake. All right, let's get a different color one more time. Now, as I said, the 3 goes with the iron, so that means its iron is in +3 state, which what causes rust. This is rust essentially. If you're looking for a chemical name for rust, there you're looking at it, Fe3+. Carbonate is CO3 2-. Okay. Now this is where you got to be careful. Now if this really doesn't bother you, you can go with this. I'm not saying all 100 students have this problem. There's always a couple that does that, so that's why I'm saying it as a caution, so you can learn from those students' mistakes that I have taught in the past. All right. So the 3 comes over here, the 2 comes over here. Now it's always a good idea, okay, I've been teaching it and I've learned it, so for me it's not a problem. And what I have seen students is do this. That is totally wrong. All right, you cannot have 33 oxygen when you should just be having 3. So let me erase it. So I am very cautious of it, maybe because of practice. So I always put it in bracket and put the 3 outside. CO3, this is not same as this. They have different meaning, okay? They're not the same. This is in fact completely wrong, because you cannot go from just 3 oxygens to 33 oxygens without actually doing a single reaction. That's just wrong. We're just writing names. We haven't made anything. All right, so if that seems to be the problem, let's go with the way where, I mean, again, you have to get into the idea of practicing. Again, the 3 is +3, and then CO3 2-. Start practicing this way, so you're never ever going to get this wrong. So let's get a different color, maybe a red. Okay, so the 2 comes over here, the 3 comes over here outside the bracket. So, Fe2 CO3 3. Very good. See just how easy that was. That's because I ended up with the same thing. This is correct. Okay, I should get a star or something. Okay, like a smiley face maybe, I don't know. Very good, right? Little hat, okay, and a little bit of drooling because I did it right. All right. So anyways, the fact here is I ended up with the same structure. Doesn't matter where I start. I can do it. If you think you can do it with phase 1, yeah, go with it. If you feel, you know what, I will probably make that mistake because I think I will, then you think you should start memorizing this. Whichever way you choose, you still have to memorize it. All right. And then let's go now pick up a different one. All right. Let's say I give you Fe 2 SO4 3. Okay, this is a transition metal compound. So immediately what most students forget is that iron is a transition metal. That means it has a variable oxidation number. That means it must be accompanied by a Roman numeral. So iron. Okay, now just leave everything out. Since we're writing name, it's easier. If you see this symbol on the list that I gave you, it should read iron sulfate. Okay, now it's a question of what this number is, because the number is only specific to the iron, not to the sulfate. So let's do the reverse mapping, or reverse swapping is what I really meant. Fe2SO4 3, let's get a different color. Okay, so the 3 goes over here, the 2 goes over here. Iron is a metal, so at this point you shouldn't have that basic confusion, which one should be positive, which one should be negative. I've said that repeatedly, metals are positive. So iron is +3, SO4, leave it in bracket and put the 2 minus outside. So we know that iron is 3 plus, so it is tagged 3. Now the key here is you've got to memorize these things. Okay, there is no getting around it. Okay, this is sulfate. Okay, sulfate is SO4 2 minus. This is sulfate right here. Now I know it because I've at least taught these things for a long time, but if you're not, there is no getting around it. You just have to remember those. Now that's for transition metal, given compound, right name, given name, right compound. Let's look at a couple for our alkali and alkaline earth metals. So let's say I give you this Na3PO4 twice. Okay. When I give you a compound, I would usually give it to you in brackets because you're just writing a name. It's only when I ask you to write the formula given the name, you have to be careful not to do the mistakes I've mentioned earlier. All right, so as it is, this is a metal, so we don't make any changes to its name with no prefix, no suffix, just plain old sodium. Now, if you go to the list, it's phosphate. Okay, how do you know? Well, because how do you know it's 3 minus? I'll show you that in a minute. Now, because it's an alkali and alkali metal, they don't ever go with Roman numerals, and that's it. We are done. Sodium phosphate is the name. Now, for those of you that have that pestering thought, how did you know that it's only PO4 3 minus and not something else? Well, you just have to do the math. It's not rocket science. You just have to do the swap to figure it out. So now here is the problem. Here's the problem. Okay, here's a problem, and I'll tell you why. Okay, I made a mistake. Okay, I made a mistake. Okay, I should have not put the 2 here. I can't for some reason get it off. All right, please, nothing changes. Just remember that 2 was not there. Apologize for that. Okay. Now you would wonder, why did he explain everything right and then finally went back and took out the 2? Because Sodium is in group 1A. Again, I'm going back to the fundamentals, which means it can only have +1. It cannot ever have +2. It's not even possible. Okay. Now, if we so that means this must have been a 1, which we don't really find out. So sodium would, if you do the swap and the 3 goes here to the top, then we will end up with sodium +1 and PO4. Of course, this is a polyatomic anion, so it only makes sense it has to be negative. Okay, now if we swap it back, we get this compound again. And I sincerely apologize that I did write it as 2. What I really had in mind was a calcium, but unfortunately I didn't end up. So let's do something else. Let's give a name. I think this is the most complicated of the 4 that people really struggle with. Calcium phosphate. Now, here's the trick, okay? Now, this, provided you have memorized it and you've got this down. Now, this is where, despite doing 100, 200 examples and you still don't get it wrong, that means you just wasted time doing 200 of those. Okay, doing 200 is not like a big achievement, okay? So, if you can do 2 things but 2 things correctly, then that's what matters, okay? See, I've done 4 things and I've already made a mistake with a 2 and a 1. So, calcium, where is calcium in the periodic table? It's into A, right? So, it's got to be +2 because it's an alkaline earth metal and they don't ever lose more than 2. As I said, they don't have a variable charge. Only the transition metals have variable charge. So, calcium is +2. Okay, again, I can emphasize about the brackets. Okay, if you're going to take the brackets lightly, then more likely you're going to mess up and going to be frustrated for no reason. Okay, so this is 3. So now you will end up with Ca3PO4 twice. All right, I have shown you a garden variety of every single scenario for both ionic compounds, given formulae, right name, given name, right formulae, and then I did the same for transition metal compounds. And I had walked you through what common mistakes I have seen students do when they do these. If I give them, say, 5 questions, they only get 1 or 2 right, even though they think they know it, but they still make the mistakes. That is very obvious for whatever I've explained you. All right, so this is the one video that I should have posted with my week 3. I will upload it as a 3rd set. I have posted 1 set so far, and maybe this will be the 2nd set of video because this is a long one and I did it all in one go. So this is polyatomic ions in an ionic situation and a transition metal situation. There is no such thing as there is a polyatomic ion with hydrogen. But I have, like I said, I have reserved that for the acids and bases and how polarity comes into picture and how does that tie into Lewis structures and hydrogen bonding and stuff like that. That's probably week 4. I think I've said enough. So I'm going to stop here. So this is one long video, but I hope you find it helpful. So I've covered every single thing you need to know about polyatomic ions. As I said, you do have to memorize what I have shown you on the screen right here. There is no getting around it. You just have to memorize it, and from there you can write just about anything. Okay? All right. I'll stay tuned. I'll come back with week 4 in a day or 2. All right? Bye-bye.